Hey, Ish. Hey, Charlie.
Hey, Ross. Hi, Charlie.
Hey, can you hear me?
Yep.
Oh, good.
Yep.
Trying to talk and not get. I wasn't sure it was working. Hey, I was gonna say, Amer, I'm sorry I didn't get back to you. I think I saw your emails and I started writing an answer. I'm not sure I hit send, so I will get back to you. I'm so sorry. And
No,
Heinz,
it's okay. Thank you. Thanks for confirming you received it. I got your email wrong, and probably
no, my fault for being overwhelmed.
no problem.
So my apologies. Thank you for your patience.
Yeah,
But
no problem.
Heinz, it's good to see you.
Yeah, I could see you too, Drew.
So I took the document Jixon wrote last week and started and like put some stuff in it. So I don't know what we want to cover, Yogesh. We can work our way through the main doc, or I can show you what I've been, um, writing up.
Yeah, I don't know. I'm curious about what Dixon sent you, but I think everyone should see it then. Sure.
Okay. So, I mean, if folks want me to share it, I'll share it real quick, and maybe if we can take a look at. It's just, I guess here's what I'm a little worried about is I feel like if we make any progress in the other doc, we're going to come back. We're going to have to revisit it when Neil gets back. So I don't know. Because we're going to have to catch him up because he cares the most about in-band. So can you see what I'm sharing?
Yes.
Awesome. And I'll paste the link. This is a document that Jixon started when we were talking last week, and he sent it to me. And so, oh no, I'm sorry. This is the wrong. Whoa, sorry. I hit the wrong thing. That document I pasted is awesome, but this is the one I meant. Sorry, second. Well, that first doc's awesome. Yeah. Okay. So here it is. share. It says share with Jixon Joy and one more. So I'm afraid that I can't share it any further. So I may have to copy things out of it. Um, but
Can
uh,
you paste a link, Drew? I can try to share it.
yeah, I did. I did. It's the second link I pasted. CPAL proposal.
Oh, cool. Yeah, I missed that.
So
No, I don't have access. Sorry.
okay. Well, can you tell Jixon we need to make it? If he can't make it publicly available, I'll copy it into another doc.
Cool. Yeah, let me ping him.
Okay. Thanks. Okay. So I'm just calling it a CPAL.
Is it this is like is in some Google folder or what?
Yeah. See.
Internal folder?
Last week, Jixon took notes on our conversation and started a doc for us.
Drew, why like he cannot edit?
Jixon made it an internal Google Doc and didn't. I thought he gave me a doc in the OCP Google folder, so it's just in the wrong folder. So
I don't think we can hear. Drew,
can you hear me?
Yeah,
I can
I
hear you,
can
Drew.
hear.
Yeah.
Okay, I think it's just Rama. So, okay, so anyway, I'm sorry. I didn't realize this was a Google internal doc. I shouldn't be editing Google internal docs, but what I'll do is copy this doc into the OCP thing. If Heinz can't share it, I'll just move. I'll make a exact copy of this doc in the OCP work in progress folder. Can you hear me now, Rama?
Yes, I can hear you. Yeah.
Okay, so Rama Jixon started this doc, and so I didn't realize it wasn't in the the OCP folder. So we'll
Okay.
move it to the OCP folder.
Yeah, okay, thank you.
But anyway, I'm proposing. So Jixon had put something like platform action log, and I just say common platform action log, so it maps to CPER, and that way CPAL is different enough from CPER. But I don't really care about the name. We can pick a name.
I like it.
Sorry.
I was just saying I like the name.
Cool.
So, yeah.
And yeah, Vilas, I'm running with your idea.
So Drew, real quick, Jixon said you should be able to move it to the folder. So maybe that'll work.
I can't even share. If I go to share, it won't let me. Oh, now I can. Okay.
Yeah, he gave you access.
Oh, good. Okay, I'll move it. I'll move it after the meeting.
All right.
But Heinz can give you access apparently. So I tell you what, if you want access to it now, just put your email address in the chat and he'll give you access. Is that okay, Heinz?
Yeah, that works. I can do that.
Thanks. Okay, so basically, I put a problem statement in, and we have all these OCP proposals for collecting error logs, analyzing actions, and driving RAS actions, but there's no standard for the output of the analyzer, and that makes it difficult to associate the error log and the RAS action with the endpoint that sent the error log. So, if I have 8 GPUs, which one should get the action? I need to correlate the two. And it also makes it hard to parse the output of the analyzer sometimes because, if I have to do regular expressions or pour through a JSON and, everyone's JSON is different, then that's also somewhat painful. And then, we have some common fields like the error name or the error severity that we, I think, want for pretty much any output of the analyzer. And the error name's important because if I say I have problem X, I want to be able to call my partners in the silicon teams and say, I'm having error X. What does that mean? Can you help me? And it gives us a name we can use to talk about the problem we're seeing. And then the other thing we want to do is integrate the analyzers into our infrastructure. And that's kind of what I was talking to Anil about right before Thanksgiving, that we want to be able to plug these analyzers in with little effort and build dashboards and drive fast actions from them. So I can say, oh, it looks like memory's bad on this host. I'm going to, evacuate it quickly. or but to drive those automated actions, if I have to handcraft something for every analyzer, it's harder. And so I'm proposing a standard format for the analysis output called a common platform action log. And we want to identify a limited number of key analysis output fields that we need for analysis results. So like if we have a repair action, that would be something we want to call out, or a RAS action, or the severity of the error. And I want to talk about that because I'm not exactly sure what those fields are, but they should be somewhat limited. We're not going to throw the kitchen sink into the standard part. We also want a common format for the output so that it's easy to integrate new tools. We can classify the failures. We can say, well, when vendor X says do this for platform Y, it works. But when they say do the same thing for platform Z, it's less effective. And that way we can give the vendors feedback on their analyzers, and we can also decide when we trust the analyzer enough to automate actions that it suggests. And then the other thing we need to do, like I mentioned at the beginning, is be able to pass the analysis result back to the machine that sent the error log so that we can take a RAS action. And so if you have 8 GPUs and one of them sends a CPER and you analyze the error, you want to be able to send the error log, the action back to the thing that generated the error so that it can take the action. And then we also, in this format, want to be able to drive proprietary RAS features. So, we want to standardize it, but we need room for the vendors to encode things and put messages in that are, they may not be obscured or hidden, but they may be, vendor specific or proprietary to the vendor. So, it may look like a binary field, but if you have the right relationship with the vendor, you know what it means because they spell those fields out for you. And I'm not sure exactly how that works yet, so we need to figure that out. But I think it's important that this in no way blocks innovation and competition. And then this complements all the other fault management stuff. So go ahead. Someone was going to speak?
Yeah, I was just going to say one thing, Drew, right? We talked about this. It just needs to be crisp that the expected output of the analyzer is, or at least includes, an action or a proposed action, right? It's kind of implicitly stated here, but it's not actually like explicitly stated.
Yeah, I agree with you. Thank you. When you talk about this all day long, you forget to say things like that. And that's pretty important.
Yep.
So, how's the?
And some other thing, like, can this one, like, after we finalize, can it go into OCP hardware fault management infrastructure requirement down? Because it has the NIC and
It's a
all.
proposal, Rama, and I think we're going to put in a whole bunch of analysis things. But yes, we talked about this last week, and we agreed that I'd write a separate doc for now, and
Okay.
then as we agree, we'll merge it in.
Okay. Thank you.
And I guess I'm not going to put it here. I'm just going to say, I'm going to put a sentence down below that the CPALs are expected to contain, I'll just say some type of suggested action, and then spell it out. Does that sound good? Okay, and so here's where it gets fun. I drew a quick and dirty drawing of how I would propose this works. And so I'm using this GPU example because we care about CPERs from everything. So, just wanted to be really clear on that. And GPUs are kind of interesting because it's pretty common to have more than one in the machine. And so that illustrates the problem. if this GPU sends a seeper, so all the red arrows are seepers, and that's kind of the key here. You have an error, sends a seeper either out in band or out of band, and then you'll have something that parses the header and go, oh yeah, this is one of those GPU things, and it will send the GPU seeper to the appropriate GPU analyzer, and that analyzer will generate a CPAL, not a seeper. I'm sorry, I need to fix that. Okay, I'll fix that real quick. Okay, so you generate the CPAL, and then the CSP will evaluate its accuracy and determine, what policy they have for that particular action. They'll do whatever they do. But if they agree with it, they'll send a message back to the host. And so in this case, I'm just saying, well, we're going to send it back to the BMC. Well, the BMC now has to associate that action with the right thing in the system. And in this case, we had a GPU error, so we want to take an action on the GPU that had the error. So the CPAL has it has some sort of matching identification that the BMC can pretty much mindlessly go, oh yeah, I know who that creator ID is, and I will send it to them. And so at the end of the day, what happens is the GPU understands the CPAL, and the analyzer fully understands everything in the CPAL, and the analyzer understands everything in the seeper, and everyone else has partial knowledge. So do you all follow this example?
Yeah, I follow.
Drew, so this arrow, is there only one arrow, or there would be another arrow where, let's say, the part requires replacement, so it would go to DC ops?
Oh, absolutely. Yeah. And I'm sorry, I didn't show you the text. In this particular case, I was showing a RAS action, but absolutely. And I can put that in the drawing that there may be a CPAL that, that what I would do there is just draw, an arrow, you're just like you say, the DC ops. And it would be green. You're absolutely right.
The thing I wanted to ask last week, I guess I'm coming up against on it right now is, does this, support polling? I mean, is it just push?
Well, I think that the seeper collection is what drives things. And so, you can pull or push however you want. You can do long polls, you can pub sub models, all of it works. But the analyzers don't, they don't just come up with something on their own. They get a seeper. And that's one thing I want to document is, my notion of a seeper is a seeper and the seeper history. So what the analyzer would do is it'd say, okay, I'm going to look at the latest seeper. And if it has everything in it that I need, like I see obviously what the problem is from that, I'm done. But if it's something like a memory error where I want to look at the trend and try to figure out what's broken from a trend, I will look at previous seepers. And so all of those happen every time there's a new seeper generated. And you can pull or push it either way. I'm not being specific here. But then what happens is you hand it to the analyzer, and the analyzer just think of it as like a Python script, right? It just runs and spits out an answer. And so when it runs and spits out the answer, then you can do whatever you want. You can push it to your policies, or they can be polling or pub sub it or whatever. It doesn't, we're not really being prescriptive on the transport. And
The use case I was thinking of was like, let's say you're a Microsoft guy, so you have a Azure cluster and you have 100,000 GPUs, and you have a switching problem all of a sudden for the scale out. And so all of the GPUs are going to like disconnect from the endpoints and then reconnect. And so there's a seeper. And then, there's going to be probably something about the garbage that's in the registers. And so, I mean, that's in the yeah, that's in the memory. And so there's another seeper. And so now all of a sudden you're flooding the network with seepers, whereas you can set policy maybe, because we talked about policy last time, and set a policy and say, I don't want those all at once. I want you to stagger them or whatever, you know?
Yeah, I mean, Bijan, this isn't shown, right? But this is essentially a set of state points interconnected with pipelines. Is kind of what you were saying, right? And so when a seeper migrates from one state point, or anything migrates from one state point to another state point, right? That second state point can get it. It can set the policy on how it gets it, right?
Yeah.
So like, for example, here, you
Downstream.
know,
Yeah, you could do
yeah,
downstream management, right? I got you.
yeah, but like basically, like, you know, the GPU might create an error, and then the BMC might want to send it to the BMC. The BMC has told the GPU, I'm polling, or no, send me an interrupt, whatever, right? And that's between the BMC and the GPU. And then, you know, if there's a state point out in the data center, kind of the same thing, right? The data center might have set a policy with the BMC and so on, right? So yeah, I think the answer to your first question is yes, it supports any of the above, right? But
Yeah, and I think that if you like, I look at what Azure and other hyperscaler pipelines do, they generally have collectors that manage that problem, right? I'm abstracting the collection out, but you know that's a known problem, and they deal with it today, and so they'll continue to deal with it. It's just that we're simplifying the fact that you go to one place and you get all the data. So we're making it easier to collect errors, but we're not changing the fact that you can have a sudden flood of them. That's old. That's an old problem.
Yep.
Right. One other way probably to look at it is also kind of contextualize, right? That, for example, there's something wrong with the CPU or the GPU internal to a compute tray. All that and all what is required for proper fault diagnosis is present in that seeper. There's no extra information which is not localized in that compute tray. But let's say in scenarios, let's say leak detection, or these GPUs are interconnected by some kind of a fabric, and the problem is that the fabric, but the error or seeper reported doesn't have that context, right? So for that, we need to go back into the data center infrastructure. So instead of sending everything back to DC, maybe we can have first level of filtering at the compute tray, and then second level at the DC.
Yeah, and I think like we've seen outages in multiple places that affect more than one node, and and yeah, that would probably just supersede. You know, if we know the network went out and a bunch of nodes go away, we can no longer talk to them. You know, the hyperscalers usually have some way to say, well, that was probably the network problem, you know, not the nodes.
Right. So that kind of deduction can only happen at a rack level or at a data center level, right? When you
Yeah.
get similar indications or breadcrumbs across the various compute trays.
Exactly. And the problem we're solving here is machine by machine, really. And maybe we can expand it someday to the, you know, you could say, you know, have in this box on the right to say, I've seen a pattern. I've seen a whole bunch of these all at once. Something weird is happening, and then go do something special to analyze it. But you know, I think what we're focusing on here is more than just machine by machine. Go ahead, Patrick. Oh, I can't hear you. It looks like you were going to talk. Still can't hear you, I think. Okay. Well, Patrick, if we can't hear you, you can type something in, and I'll watch the chat. And I spelled this out, you know, the example, and so you know, Amer, I was thinking of repair action. You know, the device takes the action and describing the CPO. But I'll say repair. You know, I can add a repair flag. That's easy enough. And this is some stuff that I was just filling in some of the stuff that Jixon had in his template. Common platform error record is for logging errors. Common platform action log is, provides analysis results and actions to be taken by the platform. And I shouldn't have put these here, but it was kind of in the template, so I filled it out. And it says why a separate record for actions, and CPERs are inputs, CPALs are outputs. The two formats are related, and that we need to be able to correlate them so that we can take action on the right thing when we get a CPER from it. And then I stopped here, and there's a limited number of things, and I think like if I were to pretend I was Anil, he would argue type of error, and what it means is like memory.
Well, so I was thinking about that. This is maybe kind of weird and kind of dumb. Could the CPAL not just include the CPER? Like the CPER that generated, then we would just not lose any information.
I'm open to it. I guess maybe here's what I would. Okay, here's a proposal. I'm going to make a counter proposal. Can it include it in a way that we can strip it off when we send the message back to the machine?
Sure.
Do you see what I'm saying? So that we don't have to send the CPER twice through our infrastructure.
Yeah, you could just have it as mark it as optional payload or something like that, and
Well, I think that's why I was last week suggesting why can't the action be an addition to the CPER record itself, an extension of CPER itself. Then
multiple logs, right?
maybe, yeah. So it's a easy logistically. Also, everything else stays the same. Just an extension to UEFI specification.
Maybe it could be it could even be a record, a section, right? So we just send the section back.
Yeah.
It's just a section, optional, right?
So
question: if they're analyzing multiple CPER logs, come up with action, can include the multiple logs?
Well, no. So the way it would work is, let's say we're doing time series analysis. Usually what happens is you get the newest log and you say, oh, it's a memory error. And then you look back at prior CPERs and you build a pattern for the memory error and say, okay, well, it's a failed row. In that case, I would only include the last CPER. That was the CPER that threw you over the edge. It made you finally conclude that, well, yeah, I've seen enough errors on this row. I really believe it's a row problem.
Yeah, going back to your diagram, I think at one point the discussion. Sorry, Rama, I didn't mean to interrupt you. Please complete your thought.
Yeah, determining which log to attach and
the selective problem, right?
It's just the newest one. It's pretty simple. Just whatever the last one was. You're not doing a complete chain of custody. The complete chain of custody is the set of CPERs that drove the analysis, but that we don't want to send all of them back.
For other aspects, it's not easy to decide which one to pick. And
it's the last one.
Use case to attach the CPER log to CPAL.
I've got a question. What's the point of attaching a CPER log to the CPAL?
Yeah.
So the CPER log is kind of the error message, right? The CPAL is what action to take. So the CPAL has analyzed the error logs and come to a decision. So why keep any of the CPER should be kind of in a separate archival file that the CPAL works on and comes to a decision, and then the decision gets sent back through the chain.
I think at some point we'll get into creating those joints again with CPAL with CPER.
Yeah.
And I think in FMFM we had this elaborate discussion that, hey, we want the upstream infrastructure wants to have full visibility. And here we are doing essentially filtering. We are containing all the CPERs at the layer where the CPAL is being generated. And now we're losing full context, full visibility, and then we're creating new problems. Okay, how about we attach some of them, and then okay, how about we create those disjoints that we need to join back again? I think we're creating more problems than solving.
So
But let's talk about that, Yogesh. I think that having a standard hardware, like a machine parsable format, is a huge help. But I agree that we still want the full context. But last week we were saying you get the CPAL and the decoded log in JSON, and so if you have both of those as the output, one's just the message you use for automation, and one is the message the thing you use for further processing.
So I'm totally aligned with having a standard language or field or definition for raw sections, but I'm uncomfortable with stripping everything else out and also then trying to selectively, which requires a lot of intelligence, what selection, and then trying to stitch it back upstream. I think those are the problems we need to think about, and that's why I was thinking, what about we have things flowing as it is, but analyzer adds an action field, and now we did not lose anything, but now the upstream has one more field to look at. Oh, there's an action request here. Okay, I'll act on this one, and everything else stays the same.
So Drew, could you go back to your diagram showing
Sure.
kind of the flow? So Yogesh, to your point, I'm kind of wondering why on the CPAL there needs to be any information other than the actual action to be taken. So for example, if it's a DRAM row repair action, I don't need all the data that led me to that decision going back to the BMC and the GPU. Certainly within the analyzer itself, I might want to query, why did the analyzer come to this decision to repair that row or not?
Because Charlie, the infrastructure, fleet operator infrastructure has better and bigger tools, and they want to run, fleet level intelligence, machine learning tools
Oh,
on that.
absolutely. And Yogesh, I wasn't trying to hint for a second that we'd get rid of the decoded data. I was really thinking about, can we create a message that we use for sending back to the machine? And the beauty of this is you could put some binary data in that targets the if you need to do a complicated set of parameters, you can embed a whole bunch of parameters in it any way you want, because it's just a
Yeah, hold on. Let's make sure we answer Charlie's question, right? So the first thing is what Yogesh said, right? That fleet policies box, it may say, oh, let's just say it got a repair action after I don't know, DRAM correctable error or something. The specific fleet policy might be to say, nope, ignore that action because it came from a correctable error, right? So that's one thing. The second thing would be just basic, like trying to figure out what happened, right? Like I get something at the BNC, it doesn't make any sense, and I look at the CPAL or whatever, and I see, oh, whoops, it came with the wrong CPAL, like that, like that kind of stuff, and like trying to piece it together after the fact is going to be impossible, right? So, does that make?
but
Did
if
I answer
we
your question, Charlie?
So I
but I
built something like this, like I said, I built something like this before in the telecom world. And the reason, in the last part where the analyzer goes to the fleet policies, that this could be helpful is it's only for reporting. It's only to say, I made this decision based on these 4 error reports. And
Absolutely. And Bijan, what I would suggest, like what I've been arguing, wherever I am asked about this, is that really what you want to do is have a giant database that contains the raw CPERs, it contains the decoded CPERs, from the analyzer, because it'll every time you analyze a new CPER, you get the decoded CPER. It would contain the analysis results as well. So, you want it all there so that if later you get a new analyzer and you say, I wonder if the analyzer fixes this problem that I had with the previous analyzer, you can run the data back through it and compare the analysis results and go, yep, okay, this is now doing what I think it ought to be doing. So absolutely, we're not trying to prevent that at all. But when it comes to sending a message back through our infrastructure, I'm postulating that it might be valuable to structure that, and it might make it easier for us to grade the output and dashboard it if the error message is structured.
So
That's really all.
Rama has his hand up.
Oh yeah, thanks Ron for your patience.
Things here, okay, like we are putting a lot of assumptions that all pipelines are working together, all analyzers are working together at the scale of things, right? Sometimes you need to take actions even when the pipelines doesn't work, right? There is outages. Okay, I think we're putting like assuming like all the pipelines are reliable, okay, and and the and like who is taking action of analyzing the time series. Oh, this is the sleeper helped me to decode that. I think it adds a little bit of complexity.
Right.
Like
I I think the example, the memory example, probably is not the right example for this because in my head, I'm thinking, oh, there is a uncorrectable memory error. Why doesn't a firmware inside the CPU take the action and just tell me the event or there was uncorrectable, I took the action? Why to flow all that CPER, although there is a CPER record, but I don't have to wait for this whole pipeline to churn out a RAS action because everything is localized, right? There's no information about the CPU, which this entity at data center has, which the entity inside the CPU doesn't have.
I mean,
Okay.
careful about that
Oh.
assumption, Amer, right? Like that is true in some implementations today, but it may or may not be true going forward, and it may or may not be the way to do things. Moreover, I guess I just point out nothing here precludes localizing that stuff. Like theoretically, you could have this entire flow sit on your node, right? Like there's nothing about this that mandates that it's in like, some remote part of the data center, right?
Yeah, and I guess the other thing I would say here is that I've done this in firmware, and it kind of worked, but the problem is that if you memory is a great example because if you look at something like fleet memory fault management, the CPU vendors might even factor in the serial number range of a particular die rev into their conclusions when they get an uncorrected error. And they might go, oh, well, when it's this, you need to do something unusual, like, this is an emergency. You've got a bunch of bad memory. Don't just replace this DIMM, replace them all. Or it could be, oh, well, I know what happened, and we have a problem with this die rev where the row address decoder sometimes gets goofed up. And if you post package or pair away this particular row address, we have the same row address failing across multiple DRAMs. And I'm making up
Right. It's all these examples that you say, they are for visibility, right? So we need the log. Definitely we need the log. And we also need, if some action was taken, corrective action, a log of that so that we can make the whole picture across the fleet.
Well, my point is that the analysis can be richer if you pass all the information to a tool that's smarter. And
And also there's a small benefit of you've eliminated one fetch, right? So if you're just passing it along, then there's a little bit less latency because you've already passed along the error that goes with the reporting instead of having to fetch it. And so I don't know if latency is going to be an issue, but if it is, that's one way it would help.
My background is I designed the Superdome 2 analysis engine that was built into the machine. So I'm actually and there's still HPE still uses it. So I am very, very familiar with embedding it in the machine. And what I would say is that there may be some latency advantages, but generally most RAS features are designed that they don't have hard real-time requirements. And the main hard real-time requirement is usually the amount of time you take you block interrupts as part of some sort of error recovery. But other than that, there are really no.
Wait, are you talking about the mythical reset?
No, I'm talking about.
I'm kidding. I always build reset flows, and I don't remember anyone ever using them. So.
Yeah, I'm talking about, the Superdome 2 analysis engine could drive ADDC, it could drive post-package repair, it can do all those things. It's like building this analyzer into the machine. But it isn't as maybe rich. It won't know, unless, they could, HP could take it, and there's nothing keeping them from taking the FM analyzer and factoring in some of the richer data. But the way that like chip kill ECC works is that when you have a memory error, it's designed that you have a certain amount of time to react. And, we noticed that you might have an hour when you predict a crash as a result of memory before you're likely to crash. You might, maybe you can generally predict maybe in an hour time range, and that's usually enough for you to migrate off. And doing this in the fleet allows you to apply things like AI that are difficult to embed, and so you get better predictions and fewer false positives if you do it that way. So you can do it any way you want. Nothing's stopping you. But I guess, Amer, I would just say that even with memory uncorrected errors, there's some benefit to sending the error logs, up and analyzing them at a fleet level. And if you crashed because you had bad memory, you got time because you're rebooting. So that's actually a far easier one to deal with.
Not always, right? Sometimes the application will get killed, but there's no kernel impact.
Oh, sure. If you're doing poison recovery, but if you're doing poison recovery, then you're still running and you've got time. You also have time in that case. You're not going to wait and decide whether to recover. The decision as to whether to recover has to be in the kernel or the hypervisor. And that has to happen instantly. But, but then do you migrate off the machine because you think memory is unhealthy? Probably, but you might be able to, the memory vendor might be able to say that was highly localized. You can just map out some pages and plug on.
Right. There's a hardware page offlining, and the firmware can do a dynamic PPR and keep continuing operation.
But you can drive all of that through this as well and drive it smarter. So, for example, a memory vendor could look at the DRAM and say, okay, I saw this uncorrected error and I see the pattern. And
But now hang on. Drew, guys, hold on, right? I mean, Amer, you're nothing you're saying is precluded by this. Like again, right? If you just take all this and you just put it all in the BMC, then it's node local, right? You can do that. Like no, nothing wrong with that, right? BMC is part of the data center infrastructure, right? Like I guess I'm missing the thing that you're trying to.
No, I was just saying maybe the example should be more a problem that we are trying to address at a rack level, which can't be done at a compute tray or at
and Vilas, I'm trying to make the point that I think that Amer's assumption that they can do it as well in firmware is faulty. So back to my example, if the memory vendor says, I know this particular thing of memory is bad, they can tell us to map out pages that we've never seen an error on. Firmware can't do that. So we will be able to do smarter things with richer analysis and richer data.
So Drew, do you consider that
Let me give you some other analogy, actually, like, okay, think through patient goes to doctor, right? There is a primary care doctor solve like 80% of the problems, right? Then some problems need specialists, okay? And if we want to put all the patients to all the specialists, it's going to be complex issue, okay? If action can be taken, some actions can be taken with a simple log, right? You don't need time series analysis and all that, right? Are we discussing about the 20% of the problem we need this? Are we discussing about?
I would turn it around though. It's the exact opposite with hardware of what you said, Rama, because here's why. Because the reason that you go to your primary care is because the specialist is expensive. But in this case, it's more expensive to have multiple analyzers. So, and multiple paths. And sure, if you want, like Vilas said, you can embed this stuff in firmware, but you're going to get smarter answers from an external tool.
And not just smarter, right? But like if I'll say it maybe differently. If you're designing one node, this doesn't make any sense. If you're designing 10 nodes, this like you want to put it all local to the node, right? Like that's the cheapest way of doing it. If you're designing a million, or deploying, I should say, a million, or 2 million, or 10 million, it's probably cheaper to make the nodes cheaper and make the centralized thing a little more expensive, right?
Yeah. And I guess here's another example of that relates to the million nodes. If I have a million nodes out there and I realize, oh crap, I'm doing the wrong thing for memory errors. I've learned something new and I need to change my policy. It is a heck of a lot cheaper to update some software in the cloud than roll out new firmware to all the machines.
Right. Yeah, that's what cheaper in a lot of senses, right? And
Yeah.
so it's cheaper, it's quicker, it's easier. Like it's just, when you're designing a very large scale infrastructure, this is the kind of thing you would do, right?
Yeah, we like in our Microsoft, we don't want to put anything analysis in the node level because the tools can be updated faster, but like, hey, how much processing should be done? For some may require like little processing to take actions. Some may require special actions. Like I feel like if everything we need to go through special actions, sometimes the pipeline reliabilities are not as good as like you assume. Okay.
But that's
Pages,
that's a cloud software problem, I think, Rama. I mean, we just need to improve pipeline reliability.
Yeah, it is. Yeah, it is not. There are latencies involved, and you have to build.
Yeah, but so guys, what are we actually debating? Now I'm lost. Like, I think we started off by saying, hey, it would be useful to have a standardized format for actions. I'm a little lost as to what we're actually trying to.
Well, I think then there's just general questions about our overall direction, which are fair, but our overall direction is to do this because this works at scale.
Right.
I think
yeah.
The common CPAL record may have like 10, 15 fields maximum. I think it's simple, like defining what to be there. I think that will solve the problem. I think we are a little bit complicating.
Yeah. And if we can, and Yogesh, I hear you. If we decide that CPAL is a terrible idea, then we take this, list of standard things we want to standardize and put it at the front of the JSON that comes out of the analyzer. That might work too. But
it's a good idea. It's just the implementation wise, it's better off just to ride on back of what is already accepted. We already have all the decoders, software investments, everything. So why reinvent the wheel is my question, right? We just need a more spike in the wheel. So
Yogesh, I tend to agree with you, right? Like part of why I suggested that the CPER is just part of the CPAL is like it then makes a bunch of stuff easier, right? Like you don't need a new decoder to figure out what kind of error it was. Like you just decode the CPER. So your suggestion, which I kind of like, I have to think about it, but would solve that same problem. Like we're just appending to the CPER, like that might be fine, right? But like fundamentally, we, keeping all the information together and making it easy to move around, I think that's great. But I think what we should do is kind of sketch out the actual information, how it would look, and then we can go look and see what the right way to do it is, right?
Well, but I want to be clear, Yogesh's was why do we even need to do it in this format, right? I mean, were you implying we could just put it in JSON, Yogesh?
I think Vilas said it well, right? Let's try to reuse what we have, but I see your point. So many CPERs, which one is really relevant for action? Maybe create a CPER variant.
Yeah.
Same information, but very much stripped down to, one thing, which is an action and some periphery information, and everything else before and after that is already going up there. So we're not losing any context. But we have this special CPER variation which says, hey, an action is needed and why. Here's the action needed minimum information and other information. Look at the CPER time series before and after, and you'll know.
Yeah, and I think we want to store all, we need all the source data still, and we still want the decoding. And we may do other processing on the JSON decoded data. So, we certainly don't want to preclude any of that. This is really just, the automating the output from the analyzer. Okay, I think that's a good feedback.
I think internally, like previously we solved this problem. There is like 8 to 10 fields what we need to standardize. like we communicated to silicon vendors, what are those? Maybe we can bring those, like that's not a secret. I think it just
Sure.
defines what is the output of the summarizer, minimum common fields we want to have, right? I think
Yeah, that'd be
yeah,
great. That'd be an awesome start. Do you want to,
yeah,
can I give you the action item
yeah,
to
we can
fill that
say,
out
like,
here?
yeah, the few items we standardized, communicated, yeah, like yeah, I can share.
And I mean, this is going to require a discussion, but you know, I'll give you the first pass. I just threw some things in. Uh, I didn't, and I'm sharing the file with you and giving you the action item.
Great,
So I
thank
just
you.
put some obvious things in, but it needs more work, and I'd love to take someone else's list.
Yeah, I think
Okay. So it sounds like we're open to exploring the, and I guess the other thing is, and this is so let's see, the two formats are related. CPAL should have a format. Uh, how do I say that's based? Can I just say format that is based on CPER? Is that okay?
Yeah, that's fine.
And I'll just say CPER has. I'll say have. For a format that is based, and because it's not a CPER, it's got some new stuff that's standard too. So. Oh, and
Yeah, I
Tanya,
mean, you
you
say
can't
it's
hear.
not a CPER, right? But the point of Yogesh is that think was a good idea is like, let's not preclude that it's just a new CPER type as an example, right? It's a little weird, but that could work, right? So
Yeah, yeah. Okay, or I could say or is a new CPER type. I mean, I don't really care. I'm just trying to say there's some sort of relationship,
yeah,
and
or yeah.
and we can't hear you, Tanya. Sorry.
Okay, yeah, I have been trying to ask question for so long, and I was thinking,
Oh,
I know nobody's.
we were not ignoring you.
No. So, yeah, I think I had some issues on my side. The analyzer here, does it get triggered with every new CPER, but it analyzes based on all the CPERs existing in the database?
So the way I anticipate this working is it doesn't do database accesses, but to keep it simple, and I'll write this up. The way I think it should work is that we know that sometimes we want time series, and we can just ask the analyzer when we first get it, hey, how much data do you want us to send you when we send you error records? And it says, send me the last 90 days. And then I get a new error log. And when I get a new error log, I send it to the analyzer and I say, do I have any errors in the last 90 days? I bundle those up with that error log and send it. But the analyzer starts with the latest CPER. And it may be that from that latest CPER that it gets everything that it needs. It's a simple error and it's obvious what we should do. Or it may say, I want to look for some patterns. I want to look and see if anything happened in the past that might be relevant. And in that case, it can go back and look at the previous X days worth of errors. But it's entirely up to the analyzer on a per CPER basis as to whether it wants to look back in time.
But the
So the
analyzer itself
analyzer is intelligent enough that it will decide.
it's the analyzer is stateless. I just want the
Yeah.
assumption is the analyzer is stateless. It gets some amount of input, and different analyzers can take different amount of inputs from the data center. And how the data center gives the analyzer that inputs is data center specific. But
And it may
takes
not be, and it
but
may not
just
be.
but hold on. The analyzer is basically a fixed latency pipeline that takes some input, produces some output, and then disappears.
Exactly.
Right.
And all we're doing is handing it a bunch of files. And if the analyzer can have very fixed code, it could say, well, whenever it's this error, I'm done. But if it's this error, I'm going to go look and see if I had some old errors that had something in them. and it can do that. But yeah, it's not like it's magic intelligence. It's just, if I need more data from the past, I get it. Well, by looking at files, it's stateless, like he said.
So,
And the
like many,
analyzer code is coming from vendors, or the data center is responsible to come up with the analyzer?
The vendors have to do it. We don't know enough about the chip. So
it's
Tanya,
essentially something like this, that if it's a memory error, we would always say, give me last 90 days of data. And
well, I think what we do is we always give you the last 90 days of data, and then you say, oh, it's a memory error. I'll actually use some of it. We don't know. We're not presuming what it is when we call you. We just call you and say, here's a CPER, and here's the last 90 days worth. And then you go, oh, that's memory. I guess I'll look at some of these old CPERs.
okay, so essentially from a CPER to CPAL relationship is not one-to-one. It's based on however many CPER is used to produce.
Sort of. So there was the last CPER, the newest CPER that kicked off the analysis, and that is one-to-one with an action, because it's the thing that kicked off the analysis. And but there are other CPERs that might have factored, and it could even be a crash dump. You could say that, well, if I have this error and then I have a crash dump, it's one thing. If I have this crash dump by itself, it's another thing. So I don't know how you're going to use the data. It's entirely up to you.
I think let's take an example, right? Like you were talking about memory examples. Similarly, I think for faults in the system, there are sometimes correlation requirements that same signature for, let's say, logic under workload. If it gets repeated, then it's a kind of a hard fault versus transient, like to separate them out, right? So in that case, first of all, analyzers should have record of, oh, for this specific chip, we have seen that specific error signature, and then this is a repetition of the same error signature, and hence there's a correlation, and hence there's a fault.
Well,
So,
and to build on what you said, yeah, I agree. And like you could say, okay, I've had a bunch of corrected errors in the cache, and now I had a hard error, uncorrected error in the same cache. I could use that to increase the confidence of my crash dump analysis. I could say, I'm actually more confident because I've seen a bunch of errors from this cache, and it finally failed hard. So
it's okay. I mean, I think just maybe an unstated assumption, right? The input to the analyzer is an interface between the CSP and the silicon vendor, right? And a silicon vendor tool. That interface has to be agreed upon in advance, whether it's one CPER or two CPERs or an arbitrarily large number of CPERs over the past 7 days or 90 days or whatever. That has to be agreed upon in advance. So it's agreed upon, the data center sends it in, the analyzer knows what it's getting, right? And then it can make decisions based on that. A rudimentary analyzer maybe just says the agreed upon API is one CPER at a time, right? A more advanced analyzer might say, hey, give me maybe 4 CPERs or something, I don't know, right? And then it's up to the data center to send 4 CPERs in, up to 4 CPERs.
Exactly.
Right? So, but I think that's the big thing. Like that's a predetermined thing, right? And it might be different for different analyzers. Right?
And actually, I might get a new you might give me an analyzer that says 90 days, and then you might realize, gosh, that another 30 would help. And then so your future analyzer plugs in, and we call you and say, how much do you want? Now you say 120.
Right.
That's fine.
I think more realistically, you'd plug the new analyzer in, and it would publish something that said how much it wanted versus calling. But yeah, I understand that, right?
Well, okay, maybe or maybe it's a call. Maybe we
whatever. That's fine. Yeah.
But I don't really care. But I'm just saying we want it to be such that the person that writes the analyzer can change their mind, and it doesn't take a lot of thought on our part as a CSP. We just plug it in. We figure out, it automatically tells us what it wants, and we give it what it wants.
I think at least hearing the discussion, it seems like some of the confusion was like, how do you write an analyzer if you might get one and if you might get a million CPERs, right? And like the answer is like you've predetermined what you're getting.
Yes.
right? So
And then you just make the most of what you got. Exactly.
exactly, you make the most of what you got, right?
And I can write that up. I can that's something I've put a lot of thought into, and I'll write up what we just described. It's not that fancy. It's just if you need more data from the past, you look at it, and if you don't, you don't.
So how about if you have a policy that's based on like an error threshold, where some fleet vendors might decide to do row repair if they see 10 errors and they'll pull the trigger, but other fleet managers might say, no, I'm not going to do any row repair until I've seen 1,000. So is that tunability built into the analyzer?
Well, the way
Well, no, hold on.
not
I
in
think
the
you
inbox.
described you described a data center policy, right? And that's why there's that data center policy box there.
Exactly. Exactly.
Okay.
You
Yeah.
said exactly what I was going to. And so
Okay.
what would happen is you keep sending it CPERs, and the analyzer keeps telling you, yeah, you should do a row repair. And then you send it another CPER and says, well, you should still do a row repair. And after a while, you're like, okay, I got the message. My policy, you've told me enough times. You've told me 100 times I need to do a row repair. I believe you. I'm going to do a row repair.
Okay. So, but is it, if it's the vendor, the GPU vendor that's writing this analyzer and
Yes.
sending the message?
But the fleet policy is yours. So
Okay, so
so the analyzer tells you 100 times, and your policy is after they tell me 100 times, I'm going to do it.
got it. Okay, so that means then if you have very, very high thresholds in your policy, the analyzers have to be able to go back and collect enough archival failure data to be able to hit that threshold.
Well, they don't collect anything, and they don't care about your threshold. What they do is they're given a pile of CPERs. They're given a pile of CPERs that they asked for, and it's some window, and they analyze that window every time. And they may just keep coming up with the same conclusion as they get more and more data, and then you have to decide when you believe them.
But that threshold could be impacted by the
I
window.
think there is a little bit.
Yeah, hold on, Charlie, right? Like this isn't any different than exactly what happens today in like a single node run, an x86 CPU that goes into SMM, and then the SMM handler is counting 10 errors, and then it decides to do a repair, right?
Yeah.
Like that SMM handler, sorry, Yogesh, just let me, that SMM handler is platform vendor, or in this case, data center code, right? So like it's doing that exact same thing. The machine is the silicon is saying here's an error. It's counting them, and then eventually deciding on a thing, right? Here, really, all we're saying is that policy choice, which if you're designing one machine, okay, lives in SMM, here lives in the data center, right? And that's in that fleet policy box. But like the machine's still got to tell you that it had an error, right?
Right.
So, but this SMM logic is mostly state-based, right? It has record of in a way in order to make a decision, let's say for correctable.
The fleet policies, if the data center wants to implement stateful policies, that's in that fleet policies box. Right?
But Emer, I would turn around and say the analyzer has the prior, it's stateless, but it has the history of the part because it's getting the CPERs. So it's just as smart, if in fact probably smarter than what the firmware is doing when it has state.
If it is a hardware counter based thresholding, CPER would probably contain the count in the counter also. And that same actionability, whether you want to take action on that threshold or you want to override with your fleet policy.
But I guess I would also turn around and say that counting memory errors is generally a way to mishandle them.
Yeah, but put that aside, Drew, right? Like, I guess the main point I'm trying to make here is nothing here is different than what happens today, except for scale.
And we have a smarter thing giving us a hint.
Well, no. The scale enables that, right? Like disaggregate the scale enables disaggregation, which enables smarter. But the fundamental flow of information and the fundamental passing of information is the same as writing an SMM handler to go into an x86. That's like,
Okay. Understood.
All right, guys, I will have to throw some cold water on the discussion. Great discussion. Thanks for Dixon to start it. Thanks for Drew to enhance and drive it. I think we came to some good insights and agreements. Let's continue from here. Drew, maybe a good idea to, it's up to you. You want to develop it more here, or you want to just develop it as a part of the main document? But yeah. Good discussion. You're already 5-6 minutes over, so I just wanted to remind you.
You guys, if it's okay, I'll keep doing it in a separate doc till we get. I need to figure out.
Totally your call. I don't care.
Well, just so that we get Anil's revisions done. I feel like if I throw this in the mix, we're gonna be snarling two things up, and this way we can have separate discussions. But I'm entirely in favor of merging the two. I'm just want to be able to separate the discussion.
And keeping it separate also has benefits. If someone needs to take it, maybe for discussion with Jeff Otter or John, and hey, we want to, have this extension in CPR or something like that. We already have a standalone document which says what we're asking for, so that's great.
Okay, thank you so much. This was a good discussion, and yeah, I'll be around next week, so if people want to set up some time to talk, reach out. I'd love to talk to you about this and understand your thinking.
You guys, are we meeting on the 20th?
I'm thinking maybe we should take a little break.
Okay, I just like the next 2 weeks beyond that, like I'm out.
Yeah.
I think everyone's out, right?
Yeah,
I think let's meet again in New Year. We've been very passionate about this and thankful for the patient here. Thank you, everyone. But I think
this is so awesome that we're able to like we finally have a team in the industry that can push stuff like this. So I'm thrilled, and I love the pushback. Let's debate it and get it right.
Yep, agreed.
Yeah, agreed. Yeah.
All right.
Okay.
Thanks, everyone.
Happy holidays. Happy New Year.
Happy holidays.
New Year.
Yep.
Merry Christmas.
Talk to you later.
Bye-bye.